Alright, so today's question is called Evaluate Reverse Polish Notation. Okay, so let's read the statement of the problem. Evaluate the value of an arithmetic expression in reverse Polish notation. Valid operators are plus, minus, multiply, and divide. Each operand may be an integer or another expression. Note that division between two integers should be truncated toward 0. It is guaranteed that the given RPN expression is always valid. That means the expression should always evaluate to a result, and there will not be any division by 0 operation. Okay, so here are some examples. Okay, let's take the first example to see how RPN works. Okay, so this is how RPN works. First, we will take two operands out, and we will take the operator and apply to it. And next, we will see another operand, and we'll put it here, and also we'll see another operator, and we'll put it here. So the result will be 9. It's just like the explanation here. And another example, just copy it. So we see a 4, we place a 4. We see a 13, place a 13. We see a 5, we place a 5. And this is the first operator. It should be applied to the last two operands that we get. So finally we get a plus. That should be applied between the first operand and the result that we just got. So the total, it will be 4 plus 2, which is 6. And yeah, that's pretty much it, how RPN works. So here, if this information is told by an interviewer, I will normally ask, will the input always be well formed? I mean, do we get something like plus like this, or 3 minus like this? These are not valid RPN. So if we cannot guarantee that the input is always valid, we need to do more check. And also, I might be asked if the result or the intermediate result exceed a 32-bit integer, because during the computation we might get a number that is too big for 32-bit integer, so this will cause overflow. This is something we need to check. We need to clarify before diving into the code. And also, let's see if there are some constraints here. Yeah, I think nothing special. Okay, so my first thought is to use first we should clarify that the input, in what form will the RPN be given? Is it gonna be a string like this? I think probably not, because it will be hard to tell if it is, let's say here like this. It will be so hard to tell if it is 21 plus 1 or 2 plus 11. There's no way to know it. So I think the input format should be like an array, and just like this is an array, and the element, each element is a string. So in C++, it will be a vector of string. Okay, and the output will be a single number. That is the result of this RPN. And the first thought that comes to my mind is to use a stack. Let's say we have a stack. Let's use a double hash sign to represent the bottom of the stack, and we use this example. So it works like this. When we see a number, we push it onto the stack. So here we see a number, we push onto the stack, and we get another number, we also push it onto the stack. And next we see an operator. So this is the time we need some operands for this operator to work. Okay, so this is the time we'll pop 2 elements from the stack. So we pop 1, it's gone. We pop 2, it's gone. And we apply the operator on these numbers, and we get 3. And after the computation, we push the result, the intermediate result, onto the stack again, and we move on to the next number. So the next number will get 3. It's a number, so it will be an operand. We push it onto the stack, and next we get an operator, and we will do the same. We pop 2 elements, 2 operands. And we apply the operator to these numbers, and get 9, and we move on. And we will need to push the result onto the stack again, and we move on to the next. But we have already reached to the end of the notation, so we are out of the loop, and at the end we'll just return what is on the stack. And that is pretty much it, the solution that I currently have. And for this, the time complexity will be it will be O of n, where n is the number of the sum of, where n is the sum of the number of the count of the operator count plus operand count. Basically, it will be the size, the length of the string array. And the space complexity will be O of n, because when we have a very long notation, And if we get something like this, we got a lot of number, and it will proportionally grow with the length of the input, I mean the space. Yeah, so yeah, that's the time complexity and space complexity. And if that sounds good, we can start coding the solution. First, let me include some header that we'll be using, and the return value will be an integer, and the name, let's give it a good name, evaluate RPN, and the input will be a vector of string. We call it RPN. So first, as we just said, we will need a stack. So here we declare a stack, and that will be what type? It should be a string type. Is that good? I think so. Let's just move on. And I will name it, let's think of a better name. Which is called the OP, means operand or operation or ops. And okay, now we will need a we will need to iterate through the notation. So we will use constant reference here. And here we'll write some code to check what is coming. So if well, let me think about it. How do we check if the, let me move the example to here. So how can we check if a string is a number or it's a operator? Well, we can actually just use if it is plus. Let's just first hard code it, and we will improve the readability later. So if we have these character, then we will do the operation. Let's say we'll make it call it n, call it up. This will be nothing, and if it is the plus, we give it a plus. It's gonna be some ugly code at first, but we will improve it later, I promise you. And if none of them are the case, we will just push the what's coming in onto the stack. So here we check if our opcode is not empty. So this is when we get an operator. So we need to do what we just did. Pop out 2 elements and apply the operator onto them. And also we push back the result onto the stack. Okay. So first, operand 1 will be ups, then top, and we push or pop and string another string. Operand 2 will be also the top of the stack element. And here, and after this, we need to make this a string. Nope, we need to convert the string into a number. So how do we do it? I remember there is a API in the standard template library called STOI. I'm not sure. Let's just Google it. Oh, yeah? I think we got it. STOI. Yep, the default is decimal. Let's just use it. Oh wait, let me just use the value here and we pop it. We don't need this. Operand 2. Yep, now we got our 2 operands. We can make the result. Okay. And here I want to make another function called calculate. And what we are gonna do is to use the opcode and also 2 operands. Operand 1, operand 2. And here we can write the switch where we check if it is plus and we return operand 1 plus operand 2. Return here not actually hit here, so we give it a -1. Okay, so here we have to push back the value that we just calculated. Operand 1, operand 2. And at the end of the calculation, we will just return the top element. And I think that's pretty much it. The code is not very beautiful, but let's just aim for the correctness first. Here, let's try some example. Let's just use another example. Like here, we use this. Okay. And this is, oh, oops. Let's just use a block comment. Okay. This will be the stack. Right? So when we get the first n, it will be 4. It is not a plus, not a minus, not a multiply, so it goes here, and we will push it onto the stack. Yep. And second is still a number, we'll push it onto the stack. And 3, the third one, is the 5. It's not an operator. We keep push it onto the stack. And also when we hit here, for every string, opcode is not set to anyone, so it will still be empty. So it will not go into this if statement. And next we get a divide operator. This is when we have to set the opcode to the divide operator, and we find that this is not an empty, it's a slash. So we go into the execution here, and we'll get the top element to our operand 1 will be 5, operand 2 will be 13, and we do a calculation with the slash. Oops. Yep, I correct myself. And we will just return 5. Actually, it should be in a different order. The first popped element should be operand 2, because you see the first popped will be 5. It's operand 2. The first is operand 1. Okay. Yep. And we will return the result of the division, which will be 2, and we push it onto the stack. And next we'll get a plus, and also again we'll get the first the top element is the operand 2, and the second is the operand 4, and we do a plus, which will return 8, push onto the stack. And that is when we run out of the strings. So we go out of the loop and we check the top element, we return 8. I think that's pretty much it. Let me just write some code to test if we are getting it right. Oops. I think we need to enter the name scope here, and yep, RPN, it will be, oh, let's use this example. Like this, and we will call our function with this input. Let's just move this, and let's print it out to see if we got it right. Yep, we also need a IO string for the C out. Okay, let's run the code. Great. Oh, we cannot use an empty. That is kind of a very beginner mistake. Let's just use a empty space. Okay, then we also forgot the name scope here. Wow. Oh, this is another we can, let's just first make it a string when we push it, because the type of the stack should be a string. And here we also use a stoi when we are returning the number. And 6, we got a 6. Is that correct? Yes, that is correct. Let's check another example. Oops. It should be a 9. And yes, it is 9. So that is pretty much it. Again, the time complexity will be O of n, and the space complexity will also be O of n. I think it's time to paste our code on LEETCODE to see if we got it right. We also have a helper function. Okay. Yes, the test case passed. Let's see. Okay, so we've done this question, and I will optimize the code for both the readability and also maybe some performance optimization, because you see the memory usage is bad. Okay, so that's pretty much it.